Today I'm going to briefly talk about a small project which I was recently working on. It used yolov8 to train a model, trying to detect the login page, the login form and the button on all kinds of login pages, and then convert that yolov8 model to tensorflowjs, and then use that model in a browser extension. Firstly, let's talk about the yolov8 part. There are a lot of tutorials or YouTube videos about that, training yolov8, but I will also walk through, just want to make sure the completeness of my video. You can refer to other people's video as well, but honestly, the training part on yolov8 is not complete. It's not complicated. It's very simple. To do that, firstly, you need to collect a bunch of images, which I already collected some of them, not many. You can see I collected about 150 images. They are all login pages. I collected from probably top 100, the most visited websites in America. And then we can start labeling, like this, T-Mobile, yeah. And to label that, it's fairly simple. You need some labeling tool. A lot of people recommend this tool. I didn't find the Mac version, but maybe there are other tools. But on Windows version, you can download it and open it, and then you can click this open directory folder and go to the images that you collected and select folder. And I already labeled them, and you can start labeling just by creating a new box and with your own labels. For me, I only have two labels, form and button. And please pay attention, please toggle this. We need to have the YOLO format. And after you draw the bounding boxes, adjust it, don't need to be super accurate, and click Ctrl S to save it. And you will have a TXT file. Not XML, YOLO need TXT. So each file will contain a row. Each row have a class label index and the bounding box itself. I believe the bounding box may be the center X, center Y, width and height, but I'm not a YOLO expert. Just leave there. Just make sure you labeled all of them, and then we can start training. And to train it, I strongly recommend we use a Google Colab. The reason is, if you train on your own machine, I don't know if my configuration is wrong or I don't have a CUDA, it's super slow. And besides that, because of other reasons, like we need to convert it to TensorFlowJS, which I found when I was recording this video and doing this project about 2 months ago, this part is very error prone. We need to, I believe some errors happen on Windows machine because Windows machine don't have this package. There are a lot of errors in the moving parts, and we also need to downgrade the version. So if you're only using yolov8, you don't need to install these. But you also want to convert the model to TensorFlowJS. I strongly recommend to use that directly on a Google Colab to avoid those errors. I spent about more than two weeks to figure them out. But with this version, I think at least it works. So let's start training. First, let's clone this package. It will contain all the data we collected and also all the labels we have created as well. Okay, so the data will be here, and then let's install all the dependencies. Again, if you only use YOLO, you don't need to install all these. And YOLO actually will use the latest versions, but because we are using TensorFlowJS and convert that to TensorFlowJS as well, so we need to downgrade TensorFlow version a little bit, and also downgrade the TensorFlow decision tree forest version. But yeah, let's just install all the dependencies. It might take a while. Okay, seems we have some error, need to restart the session. But let's run the pip list to get all the packages. See, we mainly focus on these 4 packages to see the version, are the versions correct. Let's see. Yeah, this one's correct. TensorFlow. Yeah, and TensorFlow decision trees. Yeah, seems they are good. Okay, now we can start our training. And before we train, we can prepare the dataset. We need to prepare datasets. Let's run this Python script. So after we run this, it will copy this, shuffle the files in this folder, and put it into this folder, tfyolo data. And you can see we will have images, and we'll split them into 3 folders and labels as well. And then we can start training. So we can run this command. And let me explain a little bit in this command. It's actually fairly simple. If we go to this file, yolov8, and you can see in the train part, we actually tell YOLO, hey, we want to use your yolov8 M model, and YOLO will download it. And then we tell them the configuration of our images. So if we go to this configuration, you will see I tell them the path and the train folder and the validation folder and the classes and name of the classes. And then it starts training. Of course, you can also specify a name of your project and epochs. I'm using 50 epochs. And this probably will take quite a while, quite some time as well. Okay, I think after about 6 minutes or 5 minutes, it complete. You can see the loss is all going down, box loss, class loss, and it actually saved the results in the project name, the login detector we specified in this train. If you run this train again, it will put another folder, train 2, but we only run once, so only train here. Let's look at the result. Actually, it's not bad. The train loss is going down, precision going up. Yeah. Results, labels. Yeah, there's all the bounding boxes. Yeah, you can take a look at this trained result. But I think that finally we have these models, the PyTorch models. And actually, according to my understanding, we are not using our own model. The model itself is a YOLO model. We just tell the model to train it based on our customized data. So we're not doing we're still using the YOLO models, which I believe the model itself is really good, and I will show you later about the results. And then after that, the training is complete. Optionally, you can run validation, and you can also run prediction. For example, in here, I think the YOLO, this script will just run validation on this VAL folder. Yeah, 15 images for validation. I believe probably 120 images for training. Okay, validation is done. It will be put into login detect vol. Let's look at the precision curve. Not bad. What about this one? Yeah, this is validation result. Yeah, actually at the beginning, I'm a little bit amazed that the result is not bad, or I can say pretty good. And then optionally, you can also run the prediction. Yeah, after running this, you will have the folder here in predict. Yep. And these two steps are optional actually. All we have, the most important thing is we have here the train weights these models. And then we can convert it in tensorflowjs. Let's run this command. And yeah, I forgot to mention, when you are collecting the image, the image size dimension is not important, or does not matter much, because in the end, when you train the model, everything will be scaled to 640 by 640. So yeah, you can use different ways to capture your image. Start to converting. Let's wait a bit. Okay, seems converting is already done. It's saved in our project name, login detect train, weights, the best web models. Yeah, and then we can, I will zip this file and download it. Okay, this folder, this zip file, this our TensorFlowJS model. Please download it. For me, I already do this before. I already have it. I put it in here. After downloaded, let's put it into tfjs models, yolov8. This is the TensorFlowJS model we just converted. And then we can start to build our extension. And before that, I want to briefly talk about the extension, which is, the extension is running in the browser, but the beautiful part is the extension will have a background script, which we can load our model there. So actually, the TensorFlowJS project, which is already available for a long time, but this is mostly used for web apps. It is running a TensorFlowJS library, which enable you to do the model training, model prediction by JavaScript. You can use that in your Node.js server, and you can also use that on your front-end web app. But we can also use that in the browser extension. So let's build the extension first. Of course, we need to run yarn install dependencies after, like other front-end web app development. And after you run the yarns install and dependencies, you can run this command to build the extension itself. It will take some time, but in the end, it will use Webpack and copy some folders to here. So you can see we will have some background script, which is very important, which I will show you later. And we will also have our yolov8 medium-sized model here. Let's wait a bit to its completion. Okay, and then we can load it. Let's go to the extension, enable developer mode, and we can load it here. Yeah, this we just built. Select folder. Yeah, it will have this service worker. The service worker is actually the background.js in our distributed folder. And you will look at here, and let's refresh it. Go to network. Actually, you can see it's loading our model here. So which means we have some model running in extension. So it is independent on your web app. So now we can use this web extension to do some fancy prediction job. Like here, let's refresh this page. And let's right click it. Yeah, this context menu is also created by the extension. Let's run predict. The first time it might need some time. Oh, okay. Yeah, not bad. And to my surprise, this is Japanese website, but all our training data is in English, but still it can find it. And for example, this one, let's refresh the page. And let's remove my email address and web core predict. Yeah, this time much faster. And Twitter. Web core predict. Yeah, the login form probability is low. The button is accurate. But as we can see, we successfully predicted on arbitrary website. The mechanism is when we click this predict button, the browser extension will take a screenshot of your tab and then send it to the service worker, and service worker will make the prediction and send the result back to the website. And then the content script running on this website, the content script of extension running on this website will plot these bounding boxes. There are some small challenges we need to pay attention because if you are using YOLO, the result will be directly sent, the bounding boxes. But if we're using TensorFlowjs, the result is the raw data. So probably we need to do something like, let's go here. We have something. Yeah, you need to do something like non-max suppression, and also need to do some scaling. Let me find it on content. I believe in scripts. Yeah, do some scaling because the YOLO model is always 640 by 640, but your image the dimension varies, so you need to do some scaling and then plot the bounding box. But the idea is not complicated, and the result is really, to my surprise, not bad. So I'm thinking what we can do in the future. Actually, this small project was one of my company's hackathon. I'm very excited to see the result is promising. And I'm thinking maybe we can do something very fancy in the future, like with TensorFlowjs, we don't need to use image model. We can use any other models. and we can maybe using large language model. I'm not sure. I will keep trying, but this is basically what I would like to share with you today. Thank you very much for watching. Have a good day.